So that's what y'all are listening to. So I've got some good techno. Some people listen to techno, and some of y'all are going to listen to who? So I have to vary what you listen to. So some of you listen to techno, so you got some Armin van Buuren going on, Above and Beyond going on. And some of y'all might listen to The Doors. Why not? That, you were going way back for that one. But okay, so you're going to listen to The Doors, which is probably the exact opposite of techno right now, right? And so this is what I'm going to vary. We're going to call that our independent variable. It's what I vary. I independently control. You are listening to Above and Beyond or Armin van Buuren, or you're listening to The Doors. The outcome will be our other variable. So that's going to be the dependent variable. It depends on the level of the other variable, or we suspect that it depends. So the number of accidents we would expect would vary by which one people were listening to, whether Armin van Buuren, Above and Beyond, or The Doors. And these are our two, the independent and dependent variables. So I'll give you an example. I'll let y'all use your clicker so y'all can get some credit and vote today. So I love to hike and I love to camp. And let's see if we can turn this into an empirical question. I am out here. This is taking Cedars of Lebanon Forest in Tennessee. If you've never been, great little camping ground. And I am backing into a spot here, and my truck has one of those rear view cameras. And I'm backing into the spot, and I hit a tree. There it is. I've hit a tree. And so now I have a guess, a hypothesis, a suspicion that video cameras contribute to accidents. Not video cameras, rear view cameras. So there are various ways I could get at the truth of this statement. Here's one way. Do you think that rear view cameras contribute to accidents? So one would be A is yes, B is no. So one way to get at this answer is I could just ask y'all. Do you think so right? You have a rear view, it shows you A is yes, B is no. Do you think, you know the rear view cameras, or you're backing up and it's like, it shows you in your rear view mirror also a rear view camera, and so you have that, and you have two side cameras. Do you think they contribute? So I don't know if they do or not. So one thing I do is I just ask people. So do y'all think they contribute or not? A is yes, B is no. I don't know where y'all are at on this one. All right, so y'all say yes. So that's one way of getting at this question. Now, I haven't proven it, but how can I experimentally test if they actually do? All right, so my intuitive, so my guess after I hit the tree that grew spontaneously behind me, I was like, stupid rear view camera. So I'm like, okay, rear view cameras contribute to accidents. So one of the things I can do is I can ask people, right? In your experience, what do you think? And then we find people say, oh yes they do, and then we go, we can even think of reasons. And I forgot your reason. You were telling me why you think they contribute to accidents. Oh, sorry, what can I do to test this? So what can I do to test it? You said see if people who have more rear view cameras have more accidents.
See if the people who have rear view, whatever it's called, rear view cameras has been an accident or not.
All right, so I can basically go out and do a sort of natural correlation, right? So people who have rear view cameras are more likely to have accidents. That's awesome, but it could also be what? I go to buy a car and I have lots of accidents. So what do? Is it reasonable to think if I've had a lot of accidents before that I might think a rear view camera would help me?
A lot of newer cars have them in there regardless.
Yeah, a lot of newer cars have them there regardless. But if I'm just going out and doing a natural thing, right? And I go, okay, I look, rear view cameras and cars. People who pick cars with rear view cameras, the number of accidents they've had. There could be a third variable. It could also be the case that people who pick cars with rear view cameras do so because they are They're prone to accidents. So, I don't know, a naturally occurring situation. Well, there are other things I can do to try and get at whether or not rear view cameras actually do cause accidents. I can ask, that's one thing. I could try and test by looking for natural correlations, or I can do an experiment. I can deliberately modify my variables. In this situation, how might I deliberately alter my independent variable of rear view camera? I sort of think about how I might do this. I'll give you all a second. So we're going to run through some things here. We're going to come back to how might I deliberately test this for you. It's easier said than done. This is really, really tough, and this is why you will probably take a class in undergraduate. If you go to graduate school, you'll also take a class in graduate school on research methods. It's really tough, but there are two basic issues that crop up. One, picking an appropriate sample. I have to get the appropriate sample of people to test my suspicion on. Step one. Step two, I have to eliminate any idiosyncratic variable. I love the word idiosyncratic. So I have to eliminate any variables that are peculiar to any group of people. Now, I have simplified something beyond belief, but I think this will get us started. All right, if I'm interested in the rear view camera problem, right, I could ask y'all, that's sort of one. I might even, my sample of people might be people, it's still of people who have and don't have the cameras, but there are third variable problems going on here. See what else I might do. Well, I would love to get a sample, I would love to get a random sample of people that I would like to apply my results to. So, in this case, what would be a random sample of drivers? Are y'all a random sample of drivers? Let y'all vote. Do y'all think y'all are a random sample of drivers? A is yes, B is no. So a random sample means anyone in the population, I'll just go give you a definition. A random sample is where all the individuals in the relevant population are equally likely to be chosen. So you can change your vote if you want to. Do you think you're a random sample of the American population of drivers? A is yes, B is no. So we are at 3, 2, 1. Survey says no. Okay, why no?
We're all
Just-
about the same age.
You're all about the same age, right? There's no one in here. I may be the oldest person in the room. Sweet. Where's that respect? Nowhere. All right. So I'm only 39. I realize that for many of y'all, that might as well be 1 foot in the grave. But there's no one here who's 80. You know. One group is going to be given rear view cameras, and the other one's not. Any questions about this sort of trick that I'm doing? So ultimately, I hope, is that I basically have two groups that are really, really similar, and that when I test them, the only difference is going to be this. So I got an appropriate sample. It's not y'all, it's much larger. I'm going to randomly assign some people to get a rear view camera, some people not. And these are my independent variables, and then I'm going to do what? I've given you all cars. What am I going to do? Observe. Yeah, what am I going to observe? I'm not going to observe you driving, because what's my dependent variable?
Does it lead to accidents or not?
Accidents, yeah. So I'm going to basically observe how many accidents y'all have. That's my. I mean, I could observe many other variables, but that's going to be the one for this particular study. So let's to give another example. And so I'm just trying to show you how this idea can play out in many fields. Let's say I want to know if the perceived source of a quote influences how much people agree with it. So, okay, I have my population of people. Let's say it's the entire American population. I'm going to get a random sample of that population, right? So, I have the whole population. I get a random sample of sufficient size. And my independent variable, I need a way to define source of quote, right? And the way I've defined source of quote is I'm going to tell some people the quote comes from the Bible, and some people I'm going to tell them the quote comes from Marx. Same quote, right? So I'm going to vary my independent variable. Some people I'm just going to go, do you agree with this quote from the Bible? Other people I'm going to give them the same quote and tell them that it comes from Marx. And then I'm just going to ask them their agreement. Do you agree or disagree with the quote? I usually do this experiment in class, but it requires us to do heads up, 7-up, and people have not liked that in the past. It's like, why do I got to put my head down? I don't know why. But I'll tell you what I've done in the past. Is I've shown, and you can do this at home. You're going to get get this. There's this beautiful, beautiful painting by Millet called The Gleaners. And what's going on in the painting is there's a law in France at the time that allowed the poor to go behind the people who were cutting the wheat, and the poor were allowed to go into the fields and pick up any wheat that had not been taken. They were gleaning the remains. And so one thing you can do with your friends, if you're interested, you can take this. It's a great little experiment. With some people, you can say, this French law comes to us from a verse in the Bible. Like the French were following this verse in the Bible where God commands. That's what you can tell to one group of friends. And you can tell another group of friends that it was part of the proto-communistic policies of Karl Marx. Right? Communism, right? Well, what do you, intuitively you predict that when people see the quote, and here's the quote that I give them, when you reap the harvest of your land, you shall not reap all the way to the edges of your field or gather the gleanings. What do you think will happen when I then go, do you agree with this policy? If you were guessing the outcome, I've done this before in classes. Jessica, what do you think the results are going to be?
I think people would respond more positively if they were told it's from the Bible.
Yeah, if you say this verse comes from the Bible, you tend to get more support. Remember, it's not universal. What you tend to do is, if the curve for agreement for the Bible looks like this, the curve for the agreement to the Marx looks like this, and on average, it's less. Even though it's the same quote. And this is a real phenomenon that the perceived source of quote influences how people interpret it. So in this experiment, the independent variable would be where you think it comes from. The dependent variable would be, do you agree or disagree? Good? Bad? I like this. Y'all should do this when y'all get these and see. It's really kind of cool because it's like, people are like, oh, that's Marx, that's communism. And you're like, it's all right.
Do they not ask what it means?
What?
Do they not ask you to interpret it?
What are you having trouble with?
No, I'm not. I'm just saying, I feel like if someone asked me if I agreed, I'd want to make sure that I understood it. Even if
Okay, it means that when we all have wheat fields. I mean, I have one. Yeah, I mean, who doesn't? I mean, if I were just to go, hey, this means, if you had a wheat field, make sure you leave some for the poor in the community. Or if you cut things down, you pick up a pile of wheat and there's going to be some pieces that fall out. Don't bend over and pick those up. Right? You could explain it that way. The real issue is, if you think this came from Marx versus the Bible, do you think people are going to differ in their support of the claim? Or you could do this with presidents, like you could find quotes from particular presidents and claim it came from one or another. And go, in today's political climate, I'm sure you could find Bush quotes and Obama quotes that, could reasonably come from the other, and go, oh, that's actually Bush, not Obama, who said. The Daily Show does that all the time, if you watch that show. Well, I'll give you one last example to pull all of